Hello.
Hi. All right, so let's start solving the question.
Okay.
All right. So in the beginning, they said senior, adult, child, all of them are given 0. So I just wrote 0 in the first row. And then the next thing was input type. My first type was S. So I input type S into a new row. And then the next thing was is type equal to S, which it is. So yes goes to senior is given senior plus 1. So 0 plus 1 is 1, and therefore I wrote 1 in the same row. And this line was going back to this arrow. So input the next type. The next type was again S. So I wrote S in the third row, and then increment senior again because they said senior is given senior plus 1. So 1 plus 1 is 2. So this place got 2. And then the third one was S again, S, and then senior is incremented, so 3. And the third one we were at, sorry, the fourth input we had was A, this A. So A, when we said A, this decision box just becomes rejected. So it goes to no. And then is type equal to A, which it is. So adult is given adult plus 1, which is 0 plus 1 is 1. And therefore we got 1 in this row with the adult column. Similarly, we keep going. C is the next input that we had and type. So C is given here. Type is not equal to S, it's not equal to A, but it's equal to C. So child is given plus 1. So 0 plus 1 is 1. We incremented it here. The next thing was also C, and we just keep incrementing. You notice a pattern here, right? Is that they're basically counting the number of seniors, they're counting the number of adults, and they're counting the number of children. So going with that process, I just whenever there's a C, I increment the child column. Whenever there's an A, I increment the adult column. And when there's a senior, I increment the senior column. So right now I was at the second C. So C is given 2. And there was another C again. So 2 plus 1 is 3. And then A here. So A and adult is incremented. This was wrong. This is the senior column. I had to increment the adult column since it's A, so 1 plus 1 is 2. And then A there's another A, so 2 plus 1 is 3. Another A, so A 4. One more A, so A 5. W, there's one W here. So I'm gonna write W first, and then let's go back to these because we don't know what W does. So is type equal to S? It's not, it's W. Is type equal to A? No. Is type equal to C? No. Is type equal to Z? No. So it goes back into this loop and it inputs the next. It's basically this flowchart is ignoring W. Let me just write that properly. It took type as the input, but it's not doing anything with it. It's not incrementing anything else. So we just ignore this and then input the next type. The next type after W was S. So S here, and then S increments senior. So the last thing we had was 3. 3 plus 1 is 4. So 4 here. And then S again. So S, 4 plus 1 is 5. And then D here. But we don't have anything for D. Is type equal to A? No. Is type equal to S? No. C? No. Z, we can't go through this, so we're gonna go to no and ignore this. The next thing we had was C. C here, C here was for a child. So child is incremented, which is 3 plus 1, which is 4. So the next thing we have here is Z. Now when we have Z, it's not S, it's not A, it's not C. When type is equals to Z, it goes through this yes arrow, and it says output seniors, senior, and then output adults, adult, and output children, children. Whatever's in the quotation mark is always printed as it is. So because we exited this loop, we're gonna go to the next row here and start writing it here. So output seniors. I'm gonna write seniors. Seniors, and then in front of this, I'll write the last data in seniors, because here they said just comma and then senior. So whatever is in this senior variable, I'll output that. So 5, and so I'll write 5 here, and then comma. I'll put adults. I'll write adults as it is because it's in quotation marks. Adults, and then adult. In adult, the last data that I have here was 5. So 5, and then I'll put children, child. In the child variable, I have 4, so I'll write 4 here. So this is my output. It just ends after that. So do you understand?
Yes.
Okay, let's just compare the answer as well. It should be seniors 5, adults 5, and children 4. Seniors 5, adults 5, and children 4. Yeah. Okay, the data is correct, but another thing you'll notice here is that they split they split the 3 outputs into 3 different rows. Now, this is because in our flowchart, they said output and then this, and then they wrote output again in caps lock and then output again. They could have as easily made 3 different boxes of the parallelogram, the output box. But they didn't do that. Instead, they decided to just use one box, but they still output it 3 times. So instead of writing all of this in one row, I'm going to split this into the number of times they wrote the caps lock output. So instead of this, I'll write adults in the second last row and children in the last row. Okay?
All right.
Yeah. And yeah, that's it. Do you have any question?
No.
All right. Okay. So let's move on to the next topic. We're still going to do some practice questions through the textbook, but it'll come along the way. And where is the textbook here? All right, so before we move on to more examples, we're going to look at what pseudocodes are. So pseudocode is a simple method of showing an algorithm using English-like words and mathematical operators that are set out to look like a program. So how to write, okay. We're going to go in more detail of pseudocodes a little later, but the basic example of it is this block of code right here. So this here, it says repeat, and then wait 10 seconds, get time until time is equals to alarm time, sound alarm. This block of pseudocode is basically the pseudocode for this flowchart that we had above, which is start, get time, time is equals to alarm time, no, then repeat. If it is, then sound alarm and end. So it wrote down the loop that we had, which was right after start. It was right after start we had this repeat, right? Because we're going into a loop. So they wrote down repeat, and then whatever's inside the loop, we write that down. So get time and wait 10 seconds. Well, here they used 10 seconds instead of 30 seconds. In the flowchart they were using 30, but we can ignore that for now. Get time, and then until the condition we had was in the decision box. So time is time equal to alarm time? Yes or no. So here they wrote until time is equals to alarm time. Sound alarm right after the decision box. It was sound alarm and then the end. Now, the way they wrote this, there are multiple ways to write pseudocode for the same program, for the same function. They used so what's called a repeat until loop, and there are basically 3 loops that we're going to know about. One is repeat until, another is while, do, end while, and one more is for, to, next. Now, these 3 loops are gonna, let's go to chapter 10 for this first, since it's gonna, okay. So the 3 loops we had, where is it? Here. So yeah, these 3 loops were the ones I was talking about. For, to, next, this loop basically says a set number of repetitions. for the for to next loop, you need some sort of boundary. For example, for 1 to 10, do a certain function and then go to the next part. So let me take an example here. For example, I want a program that counts. That is way too thick. 1 second. So I want a program that counts the number of steps that I take. Like, you know, those fitness applications like Google Fit and so on. So I want to make a program for that. Now, I could do this with, you know, I'll try doing this function for all of these loops. Like I can do it with multiple ways, but the only thing that's concerning here is that for the first one, for the for to next loop, I need a boundary because I need to know how many times I need to do this certain condition. So I'll say that count the number of steps I take until I reach my goal, 6,000 steps. Okay, so let me say that. Now, the program I'll make for this is going to be for 1 to 6,000. 6,000, not 60,000. 4 to, and then the code starts from after this. Okay, the code starts for the block of code I'm going to repeat 6,000 times is going to be count equals to count plus 1. Now count, what is count? I haven't actually declared anything into count. This is just a random variable that I made. So before this for loop, I'm going to write above this count is equals to 0, and then count plus 1. So as long as this continues, it will keep incrementing. Count is equals to count plus 1. And next. Now here, for 1 to 6,000, what am I counting here from 1 to 6,000? I'm counting the steps, right? I'm going to write in this place. Let me make some space first. I'll write in this space for steps equals to 1 to 6,000. Count is equals to count plus 1. And next steps. Now there's a mistake I made here. Are you able to like tell what this is doing or what mistake I made?
In the next steps, I think.
In the next steps, because here what this means is that for every step I'm counting more steps. Like this is going on and counting till 6,000. What's the point of having a counter when I already have a count of 6,000? Like if I need something here, I need to keep track of the number of people or something that makes this code meaningful. So what I'm gonna do is that I'm gonna change the statement that I have. I'm gonna say that for 5 people, I want to measure count number of steps. And I'll set another condition that, and if the steps is equals to 6,000, if the steps is equals to 6,000, then goal is reached. Now let me do this make a code for using the for to next loop for this. Okay, let me make one for this. Now I said that there are 5 people for which I need to measure the steps, and if the steps for any one person reaches 6,000, then that means the goal is reached for that person. So I'll write down here for person equals to 1 to 5, and then I'll start the code here for person is equals to 1 to 5 steps. I'll make one for steps of that person. Steps for person, and is equals to 0 initially, because right now for every single loop I want this to be a new counter to count from the beginning for every individual person. So steps person is equals to 0, and then steps person is equals to steps person plus 1. So I'm just incrementing whatever was previously here. So if the person takes one more step, then increment it to 1. But again, I said if the person takes another step, how will I know if that person has taken another step or not?
I mean, it's in like for person equal to 1 to.
For a person, I could do like the number of steps counting.
Yeah.
Yeah. So I mean, I could take that as an input from the user. So I could say input value. I'll just say val. And what this value will hold is basically the steps taken at a certain time. So for example, from 10 p.m. to from 10 a.m. to 12 p.m. Person 1 walked about 1,000 steps. So I want to basically make this val, I'll give it a meaningful name so it's not confusing. I'm basically making this val store the total steps for one person throughout the day. So let me say person total. This person, okay. So this person total is just getting an input value from the user. Let me call person 1 some name. Yeah, could you give me a random name?
Alex.
Okay, so Alex is basically going to input some data, like for example, 1,000 at one certain time. Now he does this, and I use this total to add it up to the total of the person in general. So steps person is equals to 0, input person total. Steps person is equals to person total plus steps person. All right, now this adds this up. Now, another thing is, what if Alex decides to, go for a run in the evening later on? So this will only run once here for one person. I want to make sure that he can keep adding his steps throughout the day. So that means there's going to be another loop inside this. That means this is going to be inside, I'm sorry, not before the assignment. In this place here, I'm going to write repeat. I'm using another loop, another kind of loop inside the for loop. Repeat. Repeat input person total, steps is equals to person total plus steps person until when should this part repeat until? It will repeat until let's say that let's say flag, I'll set a flag for this, until flag is equals to true. Now, what is flag before the statement here? That means I need to assign this initially. So I'm going to assign this before the repeat loop, but after the for loop. Flag is given false. So what I'm giving flag is basically flag is telling me when it's true, this means that like Alex is done inputting all the data for the day. Entering data at true. So as soon as this flag becomes true, that means this section, let me change the color for this. That means this section will stop repeating itself and exit this loop, but it's still inside this bigger for loop. Now, when it's still inside this for loop, we need to exit this loop. So to exit a certain for loop, we're going to use a statement next what? Next person. Do you understand?
Okay.
Okay, so there are certain things that I'm skipping around this, but basically I basically made a pretty complicated statement or function, which is why this is getting lengthier. But let's try a simpler one, where it's just using the separate loops individually. Now, what do you know about the conditional statements?
I don't know that.
Okay, so in flowcharts, remember how we had the decision box?
Yes.
So those decision boxes are conditions, right? They're telling you that they're saying that if for example, what question did we have? Let's take a random decision box that they had. Yeah, here. So they said, is the num equal to 1, yes or no? This is a condition over here. This whole part is a condition that they're asking you to compare and find out whether or not num is equal to 1, right?
Yeah.
So in pseudocode, the way you describe this is there are basically multiple types of ways you could describe this. Similarly, like as similar as that is to loops, like loops can be multiple kinds, where in flowchart it's just described with one single loop. In pseudocode, it has repeat until, it has for to next, it has while, do, and while, these three loops. For conditions, similarly, there are multiple ways. One is the if, then, else statement. Let me open the textbook. One is the if, then, else statement. It's here. Right, so there's the if, then, else, and if. This one is basically saying, for example, if an age is lesser than 18, then print child, else print adult, end if. So what is this doing? It's just saying that it's like a small, short program where it's saying that conditioning a limit to a certain age. So if let's say Alex is lesser than 18 years old, then print child. So it's outputting data onto the screen, which is child. Otherwise, if he's greater than 18, else means anything else. If it's not lesser than 18, then if the age is equals to 18, or if the age is greater than 18, then it prints adult on the screen.
Okay.
Right? So this is what a conditional statement does, and this is like multiple conditional statements like these are used inside programs. Like we did in flowcharts, we were using multiple decision boxes. So like
Oh,
there's another example here. So if then else is one kind of condition statement. The other kind is case of, otherwise, and case. These triple dot mean that there could be any block of code inside this. So case of, let's take this code here. Case grade of, grade, they just used a variable called grade. So case, in the case that grade is A, in quotation marks A, then print excellent, B, then print good, and C, then print average. Otherwise, if it's anything other than A, B, C, then print improvement is needed. So it's considering multiple cases. This case of, otherwise, and case condition statement is often used when there's a lot of conditions that you need to fulfill, but you could use the same one. I could make this same program using the if then else condition statement instead, but it would be a lot lengthier because I have then in the middle as well, and other, like, I have to use, if I was doing this. Okay, let me try to make this code. Let me try making this code into the if then else condition. Okay, so what do you think that would start with?
um, if I think
Yeah, if
wait, if grade equal to A,
yes, so if grade is equals to, in quotation marks, A, then
print excellent.
Yes, exactly. And this, I've done this. Now, if it's not A, if it's something else, then I'm not going to write, I don't need to write another if statement. What I can do instead of that, which would be a lot more efficient, would be that I wrote else if. So notice how here it was just else, and just only else alone means that anything other than less than 18. So instead I'll write else if grade is equals to B, then grade is equals to B, then print good. I'll do one more because I have C, else if grade is equals to,
C, print, then print average.
yes, print.
Why did it say else if?
It says else if because if I just did if I just did else instead of else if, then that would mean anything other than BC. Even if it's D, then I'd be printing good instead of ignoring that. So if I have another condition inside my else case, then I need to write else if. And I'm going to use just else alone in this as well because notice how it went 2 times. So notice how in this part it says otherwise print improvement is needed. I'm going to do that too. I'm going to write average here first. Let me just finish this one. Average. And now here I'll write else print. So for anything else, even if it's D, E, F, I'm going to print improvement is needed.
Yes.
And then end if. So notice how here, over here, I'm writing else if, over here, I'm writing else if. But for this one, I'm leaving it as else because this is for any other case. Like if it's not A, B, C, then whatever comes after, it'll print out improvement is needed.
Okay.
Okay. And because you notice how many lines this is taking. This is taking 1, 2, 3, 4, 5, 6, 7, 8. It's taking 8 lines. And for even one process, like for example, comparing is grade equal to B, it's taking 2 extra lines, where in the case condition, I could just make these code in like 1, 2, 3, 4, 5, 6 lines. So
All right.
case is efficient in cases like, getting results or having a lot of data to compare. But if is also really efficient for certain cases, like for example, this one. I could have made this with a case of otherwise, and I don't need much else in there. It would still be taking almost the same amount. So it's up to you how you code. It's like it depends on the programmer, the way they find it easier for them. Okay. Unless they mention in the question that they want you to use a certain condition statement.
Okay.
All right. So these are the 2 conditions. Let's see if there's another example here. Okay. So for if then else, there's another example that they used using a Boolean variable that can have the value true or false. So here they said if found, then print your research was successful. Else, sorry.
I think the time's finished.
Oh yes, it is. 6:03. Yes, it is. Let's do more of this in tomorrow's class, and we could just do some more examples and practice questions.
Yeah, thank you.
Okay. Right.
Awesome.
Bye.